Good morning and once again welcome to my YouTube channel, Pearson the Excel International Maths by Mr. Kamoto. And in this video, having outlined the laws of logarithm, I want us to just practice a little bit of how to manipulate the laws of logarithms and write some expressions as a single logarithm. For example, part A, we are given log to base 3 of 6 plus log to base 3 of 7. And this one, it's coming from the first law of logarithm, which says log to base a of x plus log to base a of y is equals to log to base a of x times y. That is the law that is relating so much with this one. Of course, you can see this is log to base 3 of 6 plus, so we are in this format. So we need to get to this particular format. So it's just to get the product of 6 and 7, which leads us here, and this one automatically becomes log to base 3 of 6 times 7, which is 42, and that is just like it. In part B, we are saying log to base 2 of 15, log to base 2 of 15 minus log to base 2, log to base 2 of 3. Of course, this one is now from the second law, which states that log to base a of x minus log to base a of y is equals to log to base a of x over y, that fraction. And it goes without saying that what we have here is in this format, so we are required to write it in this format. Of course, we need to talk about log to the same base of the first term, which is 15, divided by the second term. So this one simply becomes log to base 2 of 15 over 3, which is eventually log to base 2 of 5. It's as simple as that. Part C, which we need to look at again, 2 log to base 5 of 3 plus 3 log to base 5 of 2. This one is generated from the law of logarithm, which says log to base a of a raised to power k, or x raised to power k. Let's talk about just okay, let's just use what we used, log to base a of x raised to power k. This is the same as k log to base a of x. In other words, the index was to become a coefficient, and this one is already in this format, so we need to rewrite it in this format because you can see that 2 is already a coefficient. And this one becomes log to base 5 of 3 squared plus log to base 5 of 2 cubed, which is the same as log to base 5 of 9 plus log to base 5 of 8, which is eventually now going to obey the first law of logarithm, which is now, because the base is the same and the logs are being added, which is log to base 5 of 9 times 8, which is 72. And that is just like the final submission in that particular case. If you look at part D, part C, you should take great care because it has two levels. Part D, we are talking about log to base 10 of 3 minus 4 log to base 10 of a half. And this one is mixed, but the base is the same. You can see this log to base 10 of 3 minus 4 log to base 10 of a half. So This one, before it became a coefficient, it was an index. It was an index, and we can look at this further and say this is going to be log to base 10 of 3 minus log to base 10 of a half raised to power 4. But this negative is going to lead us to law number 2, because the base is the same, which says this is the same as log to base 10 of 3 divided by a half raised to power 4. A half raised to power 4 is 1 over 16 log to base 10 of 3 divided 1 by 1 or divided by 1 over 16. It would have been easier if we took this one and expressed it, simplified further, like log to base 10 of 3 minus log to base 10 of 1 over 16. This now would have been easier to be log to base 10 of 3 over 1 over 16, which is basically what we have there. And of course, when we divide by a fraction, it's like multiplying by its reciprocal, which eventually gives us log to base 10 of 3 times 16, which is 48. And that is the final submission. As far as that one is concerned, please make no mistake. All right.